Hello, Nupik. This is Matt Taylor, and this is our first installment of HTM Conversations. And today we're going to be talking to Pascal Weinberger, coming to us from Germany. Pascal is currently, I think, well, I'll let you introduce yourself, Pascal. Why don't you take over from here?
Okay, sure. My name is Pascal Weinberger. I'm from Frankfurt in Germany. And yeah, I learned about HTM reading on intelligence like probably most people did. And I kind of fell a little bit in love with it because kind of, other than most other machine learning algorithms, it actually like tries to have nuance being nuance and not just something mathematical. So yeah, that's kind of what I like about it. And yeah, from that point on, I started a little bit contributing, I hope, and causing some problems, not too many. And currently, I am working at the Max Planck Institute for Neuroscience in Frankfurt at the group of Professor Singer, who kind of does mostly visual cortex, and we work with monkeys, so it's pretty exciting to be there. Yeah.
That's very cool, Pascal. So just to let you know, we've got a significant part of the Nupik engineering team in this room as well. We're all very interested in the type of stuff the community is doing. And we've been impressed with Pascal's work entering Nupik-based hacks into different contests. So I won't introduce everybody in the room, but if anyone has a question for Pascal, I'll ask them to introduce themselves. We also have some people online. So I will call on you guys that are connected online to comment if you have any questions for Pascal. But I think I would like to start with with Alex here, who's Alex Lavin, who's one of our Nimita engineers, who is, I think, interested in Pascal's work on the recent Space App Camp application that you created. So why don't you go ahead, and you may need to talk over here because here's where the mic is. But one other thing before we do that, I noticed we do have some viewers. If you're viewing and you want to ask a question, there's supposedly some QA interface on the page you're looking at that you can ask questions, and they'll stack up here. And I will get to them as well before we end the session. So without further ado, go ahead, Alex.
Sure. Pascal, if you wouldn't mind, could you give us a brief overview of the specific app for the ESA contest?
Okay, well, it's called Gaia, and it aims to solve the problem for medium to small-sized farms who cannot afford the usual procedure to measure their crop and farm health. And what the usual procedure is to like rent an airplane or something like that, have it fly over, take photos, and do like temperature, humidity measurements and things like that. And then on that data, try to find anomalies or too hot places or too humid places. And they then are used to help the farmer evaluate where to watch his field and how to prevent diseases. So what we did for the ESA App Camp is we took satellite data, which somewhat does the same as the measurements taken from airplanes. And we, first of all, like how we started is we compared the humidity, temperature, reflectance, and things like that you get from ESA satellites with databases that tell you what conditions help diseases to spread and which disease. And then we kind of built currently it's only iPhone app that warns the farmer once he has entered the location of his field where there's the most dangerous places. And then we stumbled upon time series data for these satellites that are taken every 4 to 8 days. And then I thought, well, that's something Nupik should be able to do. And kind of trained anomaly detection models and on the satellite, like on numerical data provided by satellites. And then we combine the anomaly score, especially like the log likelihood, and the data we got from the previous implementation, which is like just comparing to the disease database. And that was like 90% through the hackathon. And then we got the idea of using in situ, which means located on the field, measurements as well. And we built a small piece of hardware with a particle that does light, humidity, and temperature measurements. And then you build a gradient from the data from the satellite, which is like on top of the plants, and from below the top of the plants. And then you use the gradient to also calculate like how much photosynthesis does the plant probably do, and compare that to what is usual for it. And that's just an additional measurement. So we're trying to combine different photos, which is what is currently done. That was the main idea and part of it. Sadly, I don't have any screenshots right now, and I think you can find them on the ESA article. I would like to type the link right now, but I'm on the phone, so I can't. But probably you can just copy the link, and such that people can see it.
Yeah, I think I posted it on the event description as well, if anybody's looking at it. So a follow-up question, let me get this straight, Pascal. Your team wrote software, but you also implemented hardware for this application too?
Yep.
That's pretty impressive. And you used NUPIC to do some anomaly detection on data coming from the satellites. Did you also use it for the data coming out of the hardware on the ground?
Yeah, mainly that. Because satellite data is like times of, as I said, 4 to 9 days. So you don't really have that much data, and the time series are not that good. So I don't think we should keep that in there, because you get really weird anomaly scores, and they don't really match what you would expect to see. So I think the main point of using it is going to be the hardware, because there we can get like measurement data points for like every second or whatever we want. So
yeah, very cool. So before I open it up to our remote viewers, do you have any other questions you want to ask?
I do. Kind of a follow-up on the satellite data. What was the specific, I guess, values that you were getting from the satellites? I might just be a little confused. I don't know if it was imagery or if you're actually getting.
can you just repeat what you just said? I didn't hear anything.
Oh, sorry. Could you tell us more specifically what the satellite data you used was? Is it image data?
We used image data which was broken down by the Ramani service, which is Ramani API. Just Google that and you're going to find it. And they break down the satellite images to numerical values, and then we only use numerical values. You probably could do some image processing there as well, but given we only had 1 week of time, so we didn't try.
I don't blame you. Anybody else in the room have a question or comment for Pascal about his work?
I do have another one. So from this project, what did you learn about using NUPIC? And what would you, I guess, if there was more functionality out of NUPIC, what would it have been?
I guess that's a difficult question to ask me, because I'm like more or less familiar with NUPIC. So something that should really like using is the HTM engine also providing predictions and maybe more measurements, but just the anomaly score, just like the API does the log likelihood and the anomaly likelihood, something like that should also come out of HTM engine if one opts for that.
That's good feedback. I think it currently provides the anomaly score and the anomaly likelihood. But yeah, getting predictions would be really useful, I think. Did you use HTM engine at all, or did you have to go past it because of those restrictions?
I went past it. I kind of built. I mean, I kind of engine code such that it uses normal NewPick models and communicates to them via normal API, but I put code in front of it to also have this separation from client to server, which is what is really useful for the HTM engine. And then you can just have the models running on a totally different machine, which is then gonna die after some time.
Right. So you said you use the normal anomaly models. I assume you mean the OPF, where you created a relay model. Yeah. Okay. Anything else, Alex?
That's all from me.
Anyone else in the room? Okay. I'd like to open it up to anyone who has a comment who is online currently. I'm just going to go sort of left to right and to who I have in front of me. The first is David Ray. David Ray, if you have a comment, you should unmute yourself and say hello. I'll give you a few seconds.
Hi, Pascal. It's good to meet you.
Hey, David.
I think you're really inspiring. I love the fact that you're in the community and you're very active and concerned about HTM progress and growth, and you're doing interesting things with it, and you're a young guy and got your future ahead of you, and I'm really looking forward to seeing, you know, a lot of stuff that you're going to be probably getting into. I am kind of dismayed about your lack of use of HTM.java, though, but I guess I'll allow that one to pass. Anyway, yeah. So I don't know that I totally understand, you know, your project, you know, well enough to, you know, just really comment on it. But I'm excited to see you doing things, and I just want to, you know, just basically acknowledge you for your participation.
Thank you. It's great to hear.
Thanks, David. You'll get much higher accolades from David as soon as you start using Java. That's
well, I mean, what can I say?
Yeah. well, I will at some point, but.
All right, thanks, David Ray. Let's move along. The next person is Richard Crowder. If you've got anything,
hey.
There you go.
Hi, Pascal. Good to meet you.
Hey.
I think the only question I really had was what parts of NewPick and HTM did you end up using?
I don't hear anything at the moment.
Oh, sorry. I could hear you, Richard. What he asked was just what parts of NewPick and HTM did you end up using? I think maybe he's thinking about prediction versus anomaly detection. Maybe is that what you're thinking, Richard?
The different parts of the HTM, the poolers and the temporal memories.
Did you hear that, Pascal?
Yeah, I heard it. Okay. I didn't really deal with splitting the lab. Kind of used them both with the OPF, but to the question about predictions and anomaly scores, just talking within that app, it's mostly anomaly scores, just because you don't expect to predict conditions like humidity and temperature just from a time series. You would need like many more factors to know results from that. So, yeah.
Just to follow up on that, I think when you use the OPF, to anyone who's listening, you're pretty much using our standard configuration of algorithms by default, which is spatial pooling and temporal memory. Is temporal memory the default now? No, so it's still the old temporal pooling situation.
Still temporal memory. It's called something else entirely. And it doesn't always use that. I just wanted to make sure that non-temporal model.
Okay.
I have a question.
Shoot.
But what kind of encoder is standard for, whatever the framework he used? Like, I mean, did you have to configure your own encoder or what?
Did you swarm, Pascal?
Yeah, I swarmed, and I used the I guess it's the random distributed scalar
Okay.
encoder. I think moving on try to implement our own to get like the context of what temperature actually means and what humidity actually model. Because currently it's like really kind of thing. You only had 1 week of time, so you don't start digging too.
So the feed's breaking up a little bit, but I think I understand what Pascal's saying. So he swarmed, and the swarm recommended the random distributed scalar encoder, but I think it's a common theme when you have a specialized problem that you're trying to solve to want to try and create a specialized encoder that encodes the information properly for what you're trying to get out of the HTM. And I think that's something that will come in time. We're trying to make it easier for users to create their own encoders and realize when it's appropriate to do so. So that's still very much an open question, and how that's done is very domain specific. So I mean, it'd be awesome if we had like some type of universal weather encoder. You just feed it in some streams that can be collected at any point on the Earth, and it just does the right thing.
I guess that won't work. So to have, like, in order for that to work, you would need to have like a classifier or something like that before it just tries to classify the input, and then you have special encoders for anything, and then you would like take the decision away from the user. So kind of like the swarming process, but with a better classification. That would be a feature, especially for beginners to jump in, such that they don't have to deal with encoding. Just a thought.
Yeah, you know, one of our goals, a longer-term goal, is to have a community-established library of new types of encodings that are useful to everybody. So this is something that the community could certainly work upon. Well, let me move along to someone else who's in the queue. Roberto?
Yeah, here.
Hello, nice to meet you.
Yeah, nice to meet you guys. We do have a question here, but first, to repeat what has been said before, to congratulate Pascal for your work. Good reach and doing good things for everyone. That's nice. So we have a question here about the overall configuration of your system and platforms. Jose Luis here will ask something.
Hi, yeah, I'm Jose. I was trying to join at the separate session, but I couldn't, so I begin here with Roberto. My question is, for running the algorithms of NUPIC, where do you build the code for that? I mean, where do you process the data? In what platform were you using, or were you using a Mac or
You mean for that? Do you mean general?
Yes.
Generally, I have a Linux system, but I usually do everything in virtual machines just because it's way easier and you don't destroy your system if you start things. So I would highly recommend just you separate it. That's what we either app a virtual machine and then put it on a server we were provided with to be able to do something else besides.
So Pascal, you're still breaking up a bit,
Does
but
that
I think I got the gist of your answer, which was Linux, but mostly in a virtual machine because it gives you more flexibility to move it to another system somewhere or onto the cloud and move your processing system to a different place.
And regarding the final steps of your system, the output was then later taken out of there, say into a mobile device, or uploaded into some sort of database. So what is the overall structure of the whole project?
Okay, I want to stay like on a high level on that because I don't want to give everything away. But how many parts you have the client and a database and our the UPIC models, which are on a separate server. So what you do is when a client, like an iPhone app at the moment, requests to make a new field, then you get the satellite data for the area that field is in, and then you pull that in through the server in the middle. You save the satellite data as well as the images to be able to provide the user with that as well, and then you forward it to the UPIC server where the models are in, and then it processes, sends the data back, like the anomaly score, the anomaly likelihood, the prediction, but we don't really use that at the moment, back to the database. It stores it for later use, and then when the client goes to the map view or the graph view where all the graphs are provided, then he requests that from the server and the database in the middle and gets it from there. So you try to separate as much as possible in there.
All right.
Does that answer your question?
Yeah, pretty much.
Okay, great.
Right. Thanks, Roberto.
Thank you.
To those of you watching online, there's a few more now. If you have a question, you can type your question into the QA interface. I'm going to move on to Sergio, who is muted, and I can't figure out how to unmute him. So, Sergio, you may have muted yourself, and maybe I don't have control over your microphone. So, if you have a question, you should go ahead and unmute yourself now to ask. Otherwise, no question for now. Thanks, Sergio. Pascal, I'm going to ask you a question now.
Okay.
I'm curious about what your future plans are for your education and your career. You seem to have a lot of potential. Are you planning on continuing to investigate our method of machine intelligence? Is this a long-term thing, or just something you're fiddling with temporarily?
Well, I guess for my future right now, it's at the Max Planck, which I'm really happy with. So what my to kind of see if I can further contribute to the understanding data, the mammalian brain, like apes in that example, and try to compare that to machine learning methods, machine learning more into the. So I guess what I'm going to, if I find any properties of an SDR, like a sparse distributed representation within the visual system of the monkey, and maybe if the data to model the processing in the brain with a NUPIC model or HTM model in general, to kind of see how that compares to actual biology. And yeah.
Cool. So sounds like you're really interested in knowing how this stuff works in the neuroscience. You could be a great asset to the HTM community as your career progresses. So I hope you'll stick around. We're extremely happy to have you as a part of our community right now. Great work. And I think I've gotten to everybody. If someone else has another comment, please go ahead and speak up.
Silence.
Okay. Thank you very much, Pascal. Big hand for you and all your work. I appreciate it.
Thank you.
It's been wonderful to talk to you, and best of luck in everything in the future.
Thank you.
Take care, everyone.